assignment example. So here's your assignment right over here. And I'm going to do one from each section so you can go back and look at them if you need to. But you could use the previous video. I think you have enough information. If you use the information you got from the previous one, you should be able to do the assignment. So let's look at this first grouping. And it's find the area. So here's one that just says IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. What is the probability that a random chosen person's IQ score will be higher than 111? So again, when you think about this, you got, so we'll call this example 1. And you know that you have a normal distribution. You have a normal distribution. The mean is 100. The standard deviation is 15. So you have this picture. The question that's being posed is, what's the probability that a person's IQ is greater than 111? That's the question that we're looking at. That's how you might write it out if you didn't write out all those words. This question written in words means the same thing right here. That's the same question. Mean of 100, standard deviation of 15, probability that you'll have greater than 111. So we can do all that on our calculator. So what we're going to do is I'm going to go to the Desmos calculator. I'm going to put the mean in. Again, let me go back and let me close this out and let me show you. We could just type in, this is a normal distribution. So if I type in normal, D-I-S-T, as soon as I type the T, watch what happens to the screen. Notice it goes to a function. Before it isn't. As soon as I type in a T, it suddenly means something to this calculator. Now, it asks me for the mean and the standard deviation. The mean in this case is 100. The standard deviation in this case is 15. There's our picture. If I want to make it zoom fit, I can zoom fit it right there. There we go. 111, somewhere right in this grouping right here, right? So if we need to find the cumulative, we need to know what percentage is greater than 111, right? And we're kind of going, okay, 111 is maybe right here. So the probability that we're looking for is this grouping out here. That's what was highlighted when we did it on Desmos. So we end up with something like this. So notice that when we get that, we get 0.2316776 roughly. On the Delta Math assignment, it says to the nearest thousands. The nearest thousands would be 3 decimal places. So we're going to type in 0.232, and we should get the right answer. 0.232. You might get the same kind of thing with the statistics calculator. I've found that Desmos, a Delta Math statistics calculator, I haven't always found that to be super useful. But normal CDF, cumulative distribution function, and you go through here, you use this calculator. Notice they put this upper bound in it at a really, really big number. That's, Desmos defaults to infinity, so you could use that as well. Okay, so that's that first grouping. So let's look at the second grouping. The second grouping is, okay, now we're going to do the same kind of thing on here. So got example 2 here. And let me just do a little rearranging of my screen so you can see the whole thing at the same time. 1 second. Murphy, don't haze me for doing this, but I'm going to just rearrange my screen a little bit. Hopefully you're smiling right now because I called you out again, but here's what I got. So for males in a certain town, systolic blood pressure is normally distributed with a mean of 110. So the systolic blood pressure is the first number in your blood pressure when you get a blood pressure. The systolic blood pressure is 110 and a standard deviation of 6, and it's normally distributed. So we know that we have a normal curve with a mean of 110 and a standard deviation of 6. Here's what we got. You should be able to do that really quickly now. If 209 males from a town are randomly selected to participate in the study, how many of them would be expected to have a systolic blood pressure less than 97? Well, so we have 209 males. We want to know how many have less than 97. That's the question. Well, so to answer this question, the first thing I want to know is what's the probability that our males are less than 97? Okay? We've got to figure that probability out first, and then we're going to multiply it by the 209 males. So we're going to go to the Desmos calculator. And we're going to go over here, and I'm going to put in 110 for a mean and a standard deviation of 6. I get this really, really high thing. I'm going to zoom fit it there. Now notice that if our systolic blood pressure is 0, it would probably mean we're dead. So we want to know that to 97. And notice you get this little percentage right here. We get 0.01513. If we take that percentage and we multiply it by 209, we should get the right number. So you do use your calculator on, or however you want to do it on there, but 209 times that 0.0151314, you should get the answer. 209 times 0.0151314, get roughly 3.162. And if I go back to the question, it asks us to round to the nearest whole number. The nearest whole number is around 3 males. So if we go in here, type in 3, should get the right answer. And there we go, and it kind of shows us the same diagram. Okay, because 97, remember 97 is down here. 97 is down here. We're talking about this grouping down here. All right, so that's the second one. So let's look at the last one. And the last one's a little bit of a stretch, right? So this is the last one, and it's a little bit of a stretch from what we've been doing, because now we're comparing two different things, and we're going to stack them up, and we're going to kind of talk about what it looks like. So we got this first exam. We got exam A. And in exam A, it's known that the mean is 450, standard deviation is 25, and we know that they're normally distributed. It tells us this down here. Okay. She earned a score of 405 on this exam. So on exam A, got this gal. It's normally distributed. She got a mean of 450 and a standard deviation of 25. So 450 is here. You know that on exam A, she scored 405. So that's where she was. She was below average. So now what we're trying to do is we're trying to figure out, okay, if you have exam B that's also normally distributed, so if this is exam B, it's also normally distributed with a mean of 600 and a standard deviation of 20. So, the mean is 600. We want to know what's this, so that this area is the same as this area? We need to know what score do we need to get. Okay, so here's the way we're going to do it. We're going to figure out what this area is first, and then we're going to do a little bit of guess and check on here. So we'll go here, do our normal, and what we're going to do is we got 450 and a standard deviation of 25. It's a pretty terrible curve, so we're going to zoom fit it. We get this nice curve here. We're going to put 405 there, and we get a pretty good representation. 0 is an okay lower number. If you want to go lower, you can. But 0 is an okay lower number. Remember, there's very little out here on the tail, so it's going to work out. What we end up with is 0.03593, something like that. Notice that if I put in like -100, it didn't change that number, right? So it doesn't matter if I put in 0 in this case. That number didn't change all the way out to this decimal because there's so little over here. Now, what we want to do is we want to get this same number to show up down here on our new normal distribution. So here's what we're going to do. We're going to keep that number in mind. And what I'm going to do is I'm going to change my normal distribution. I'm going to change it to 600. Actually, I'm going to just, let me just do this. I'm going to add a new normal distribution. Let's do this. Actually, we're going to do this. Let's see if there's, maybe I can do it off of this. If I type in normal, what happens? If I type in normal distribution, yeah, that just didn't work out. So let me do this. Let me go to here. Let me go to the functions, distribution. Let me go to normal distribution, and I'm going to get a new normal distribution. It's going to be in purple. So this new normal distribution, I'm going to do 600, standard deviation of 20. Now that one's way out here. If I do zoom fit, it'll show me that one. If I do zoom fit, it'll show me that one. So I'm going to leave this one up here. Actually, I'm going to go, it'll leave this thing. So this is my new normal distribution. And I need to figure out, what do I need to plug in so I get this exact same amount here? Okay, so let me just try some things. What if I type in 500? Well, that didn't work. What if I type in 580? Nope. What if I do 560? Nope. If I do 570? And so what you're going to do is you're going to type in numbers until you get the exact same amount. 50 didn't work. 60, still a little too small. 61, 62, 63, 64. Look at 64. So my answer is 564. That's what I want for a score. If I go over to Delta Math, I type in 564 and I submit it, I should get the right value, and there it is. If you have any questions, let me know. I'm going to stop the video. Good luck.